There might be a way to beat the speed of light without breaking a single law of physics. At that speed, reaching the nearest star would take more than 70,000 years. Every idea on this list is fighting that same number, and the one fix that might actually beat it may need energy with negative mass. So let's climb this ladder. From rockets we've already flown to physics we're still not sure the universe allows. Start at the bottom, with the only interstellar technology humanity has actually flown: chemical rockets. Burn fuel, blast hot gas out the back, and the rocket gets shoved the other way. That's the entire trick. The problem is that more fuel means more weight, and more weight means you need still more fuel just to lift it. Chemical rockets carried Voyager 2 past Jupiter, Saturn, Uranus, and Neptune, and both Voyagers out into interstellar space, the actual frontier of human reach. Your entire species could rise and fall a few times over before that ship ever reached another star. Chemical rockets aren't a road to the stars. They're barely a road off the driveway. One rung up, ion drives which trade brute force for patience. Instead of one huge blast, they fire a thin stream of charged xenon ions continuously for years at a time. NASA's Dawn spacecraft used one to visit the asteroid Vesta and the dwarf planet Ceres, quietly outlasting rockets that looked far more powerful on paper. The thrust is embarrassingly weak, about the push of a sheet of paper resting on your palm. Given years instead of minutes, that gentle push adds up to speeds chemical rockets could never touch. It's the tortoise of space travel, humiliatingly slow at first, until it simply refuses to stop. Ion drives could beat fire to another star. Decades still isn't a human lifetime. Now the ranking gets uncomfortable. Project Orion proposed powering a starship with nuclear bombs. Detonate a bomb behind the ship, ride the shockwave forward, then detonate another and another. Engineers in the 1950s and 60s calculated this could push a ship to a real fraction of light speed. The ion drive's paper-thin push looks tame next to this. Orion replaces it with hundreds of nuclear blasts strapped to the ship's tail. It's the most powerful propulsion concept ever seriously engineered with real physics, and also why it never left the drawing board. Detonating nuclear weapons in the atmosphere is, unsurprisingly, illegal under international treaty. Somewhere there's a shelved blueprint for a spaceship literally built to nuke itself forward, on purpose, over and over. Orion is buildable with today's physics. Nobody on Earth is legally allowed to build it. Ditch the fuel completely, and you get sails pushed not by wind, but by light itself. Photons carry no mass, but they carry momentum, and a wide enough mirror can catch that push. Breakthrough Starshot wants to skip sunlight entirely and blast a sail with a ground-based laser array instead. The target speed is around 20% of light speed for a probe the size of a postage stamp. At that speed, the trip to Alpha Centauri stops being 70,000 years and becomes about 20. Remember Orion's illegal nuclear blasts. This swaps them for a laser array with more power than a small country's entire grid. The sail also has to survive being hit by that very beam without simply vaporizing, and nobody's solved that yet. This is the most realistic road to another star system inside a human lifetime, if the sail survives its own engine. Skip the speed problem completely, and you get generation ships. Don't go faster, just never stop. The people who leave Earth would die en route. Their great-great-grandchildren would be the ones who actually land. A voyage like this could stretch across centuries, sealed inside a closed ecosystem that is never allowed to fail. Every crop failure, every broken filter, every argument has nowhere to go. The ship is the entire universe for generations. Your descendants would grow up believing a metal corridor is the sky, which is either beautiful or deeply unsettling. There's no resupply run and no calling home. If something breaks that they can't fix, the mission simply ends in the dark. Compared to a laser sail's 20-year sprint, a generation ship trades speed for something sails never need, an entire self-sustaining civilization. We could theoretically build one today. Keeping it alive for 4 centuries straight is the part nobody's ever tested. Here's a stranger fix. What if the ship carried no fuel at all and simply scooped it up along the way? The Bussard Ramjet, imagines a magnetic funnel wide enough to gather stray hydrogen drifting through interstellar space. Scoop enough of that hydrogen, use it for power, and in theory the ship never runs out of fuel between stars. There's a catch nobody's fully solved. The drag from that funnel might slow the ship down more than fusion can push it back up. It's been sitting in physics journals since 1960, unbuilt, because the scoop itself might be the enemy. That 4th century generation ship gamble. A working ramjet could make the same trip in a single human lifetime instead. Nobody has ever built a working scoop. Nobody's even certain the physics allows one to work. Fusion ramjets sit right on the line between engineering we understand and drag equations we can't beat. Notice the pattern climbing up this list so far. Rockets, ion drives, bombs, sails, ships, scoops, every single one still obeys the same rule. Push mass through space, never faster than light. To actually beat that limit, you don't need a better engine. You need to stop playing by the rules of space itself. In 1994, a physicist named Miguel Alcubierre found a loophole general relativity actually allows. Don't move the ship through space, move space itself. Contract spacetime in front of the ship, expand it behind, and the ship just sits still inside its own private bubble. Relativity only forbids outtracing light locally, and inside that bubble, the ship is barely moving at all. Which means, on paper, a warp bubble could cross the galaxy without breaking a single law of physics. There's one catch that's kept this on paper for 3 decades. The bubble needs exotic matter with negative energy density. Not hard to get, negative energy, mass that pushes instead of pulls, and we've never produced it in any real quantity. The ramjet's drag problem was stubborn. Warp drive's problem is that its fuel might not exist anywhere in reality. Some versions of the math also need more energy than exists in the entire observable universe, depending on the design. The equations allow it completely. Nothing we've ever measured in a lab does. Push one level further. Instead of warping space around you, what if you just tunneled through it? General relativity allows a bridge connecting 2 distant points in spacetime, a shortcut instead of a straight line. Step through one mouth near Earth, and the other could open near another star, skipping the distance between them entirely. The math checks out. Einstein and Rosen described a version of this bridge back in 1935. But a wormhole's throat wants to do one thing the instant it opens. Collapse shut faster than light could ever cross it. Keeping it open needs the same impossible ingredient as the warp bubble. Exotic matter, holding the throat apart like a strut. Warp drive's missing fuel shows up again here. The same exotic matter, propping open a much smaller doorway instead of an entire bubble. It's the best commute in the universe, gated behind an energy source that might not be real anywhere. No experiment has ever produced negative energy in the amounts either of these ideas would actually need. Wormholes top this list because the equations permit them completely, and the universe may simply refuse. So does negative energy actually exist anywhere in reality? In tiny amounts, yes, many orders of magnitude short of what's needed, produced by 2 metal plates pressed close in a vacuum, the Casimir effect. It's real, it's measured, and it is many orders of magnitude too small for a warp bubble or a wormhole throat. That's the actual wall out here, not imagination, arithmetic. Every idea on this list, from a rocket's fire to a wormhole's throat, is really humanity arguing with one brutal number, the distance between stars. We already have machines crossing that gap. What we don't have yet is enough negative energy to skip it, or maybe just enough time to try everything else first. If bending space sounds insane, wait until you see what's allegedly waiting inside a black hole's event horizon. Subscribe, because that one's next.